Welcome to today's session, Architecting Business Critical Oracle Workloads on VMware Hybrid Cloud Platform. My name is Sudhir Balasubramanian. I'm a staff solution architect and I'm the Oracle practice lead for VMware.
And I'm Don Sullivan. I manage all of business critical applications for VMware. Myself am a Oracle certified master, and together Sudhir and myself comprise the Oracle team at VMware.
Very good. All right. So let's have a look at the agenda for today's discussion. So essentially, we'll start with talking about some of the benefits of running Oracle workloads on VMware platform. We'll follow that up with essentially what customers want, which is VMware Hybrid Cloud. We'll talk about some of the hybrid cloud offerings that we have today, essentially the VMware Cloud on AWS, the Google Cloud VMware Engine that got GA'd very recently, the Oracle Cloud VMware Solution, aka OCVS. We'll also zone on to the VMware Cloud on AWS and talk about some of the benefits and some of the use cases, essentially deploying and migrating Oracle workloads on VMware Cloud on AWS. We'll touch a bit on the Oracle Cloud VMware Solution, touch a bit on licensing, touch a bit on support and certification. We'll wrap it up with a lot of collaterals, and hopefully we do have time for some question and answers, but this is a jam-packed agenda for today's discussion, so let's move on. So let's take a look at the benefits of running Oracle workloads on a VMware platform. I'm going to move to the next slide here, right? But even before we start taking a look at the advantages of virtualization, right? The benefits of virtualizing Oracle workloads, let's first understand what are the requirements of an Oracle Business Critical Application, BCA, and then understand the benefits of running these business critical Oracle workloads on a VMware vSphere platform. I mean, essentially, any business critical application, be that Oracle, be that SQL Server, or be that any homegrown application must have these requirements, essentially the availability, the fact that it should be highly available, the fact that it should be resilient, redundant, the mean time between failures must be very high, the fact that the platform should be very performant, right? So that any process, any business process that we have or any customer has, the completion is very, very, very critical, right? And essentially any or all of the bottlenecks must be avoided. The fact that you should be able to recover at any point of time within a fraction of a second, right? So your RTO, your RPO, your MTD, your WRT, they should be very, very, very low. And the fact that your recovery plans must be verifiable, repeatable. You should be able to scale up. You should be able to scale out. You should be able to add CPUs, memory, storage on the fly, so that you're able to adapt, or your application is able to adapt as and when the workload on the application increases with very little reconfiguration effort, right? And of course, security is very utmost important, because we need to be secure both from internal and external attack, and essentially be compliant with the industry standard security practices. So why do we virtualize business critical application? Well, these are some of the benefits. Well, and again, this is not, like I said before, this is not particular to an Oracle BCA. This essentially helps all workloads running on a VMware platform. The fact that you're able to maximize the resources, because server resources, they increase too much for one application instance. By virtualization, you're able to improve the resource utilization, and also you're able to reduce wastage. The fact that you have enhanced availability. So essentially the native application HA features are mostly incomplete for most of the business critical applications. So for example, running Oracle RAC on vSphere HA, right, or on VMware vSphere platform, you not only get the application HA that Oracle RAC provides, you also get VMware HA, which is provided natively and innately right out of the gate, right? So you have both application level HA along with infrastructure level HA. And now if we were to stretch this infrastructure across metro distance, you get site level HA. So you get various levels of high availability simply by running an application like Oracle RAC on a VMware vSphere platform, and simply by stretching the VMware vSphere platform across metro distance. Of course, rapid provisioning, scaling, I mean, you get all of the known and the latent benefits of virtualization. The fact that you also get lower TCO, so significant savings in power, cooling, data center space, and administration as well. Don, did you want to add something?
Yeah, so Sudhir, I think it's important to look at what vSphere, that platform of virtualized hardware that we love so much, that's revolutionized the industry. What it really brings is two categories of value. That is the resource management capabilities and the mobility suite. You've talked about the resource management in detail. up at top, and of course we'll get more into it as we go along with this presentation. And the mobility suite is those, it comprises of the HA capabilities that you've already described. But I'd like to add to that point that it's so simple. You can set HA up for an entire cluster in a couple of mouse clicks. So simple that a child could do it. And it really does give you that infrastructure level HA that is almost bulletproof. And then, of course, vMotion. I remember the first time I saw a vMotion on an Oracle database running about 12 years ago, sometime in the 2008 time period. And it truly seemed amazing to me, almost like something out of Star Trek, that you could have a running database and have it transition from one physical server to the next and still keep running without a need to even to do anything. And so vSphere truly creates an abstraction layer between the operating system and therefore the applications and databases and the hardware. And when we get into the discussion, we talk about ESXi being truly a non-para virtualized hypervisor that's type 1 and therefore runs in the bare metal. It really hits home that idea of that perfect level of abstraction. The one other point I'd like to bring out is that the HA that you talk about is so sophisticated and so clever that it effectively breaches the gap between what we have classically thought of as high availability and disaster recovery. Whenever you create high availability for storage, effectively you are creating a disaster recovery environment. And so what you've done is almost meshed HA and DR together into one architecture, which is absolutely amazing. So go ahead, Sudhir. Let's talk about some detail.
Yep, very good. All right. So, these are some of the benefits of running Oracle workloads on VMware platform. We spoke about some of these points. I'm just going to list them out, namely performance, scaling up, scaling out on the fly, server consolidation, accelerated provisioning, granular workload management, high availability, business continuity, etc. Did you want to speak to this one, Tom?
Yeah, let's get back into the HA discussion a little bit and what VMware HA actually brings to you. The ability to detect operating system and hardware failures. Also restarting the database as long as the database is set to restart when the virtual machine itself restarts. This simple and first line of defense for all applications or anything that's running on that particular VM. The cleverness that you'll see later in a discussion with distributed resource scheduler determining exactly which node is most optimal to restart that particular virtual machine on to maximize, to optimize the resources being used within the cluster. And then, of course, in recent times, the proactive HA through that distributed resource scheduler. Effectively, the VMware system predicting when a failure is going to happen. So it automatically moves the VM before an event happens of some kind that could result in some downtime. And then, of course, again, vMotion. vMotion is a bit of a silly example, but it's almost like a science fiction show where one character beams himself between the ships or from the planet to the ship. I've always said that what vMotion did was it transitioned or took the idea of the physical server and separated it from the logical server. So the logical server can move around to different physical locations, can transition from one physical server to the next without it being affected, again, because of the way vSphere creates that perfect abstraction layer between the OS and those applications and the actual physical hardware. It makes ESX and vSphere make no changes to the operating system whatsoever. So in that case, the application has no idea that it's running on virtualized hardware versus non-virtualized hardware. You might have noticed there that I don't even refer to physical anymore. I just refer to virtualized versus non-virtualized. So obviously reducing downtime, and you can perform maintenance anytime whatsoever. There's a whole course that you could conceive of and take on various different aspects of vMotion, but particularly the encryption aspect of it as security becomes so much more important. And I already talked a little bit about what DRS does, but DRS, again, there are VMware luminaries that have written entire books on vMotion and DRS alone, along with HA. So I'll leave it to those folks to get more into those details as we move along in this session. So go ahead, Sudhir.
So essentially, as we can see here on this particular slide, right, I mean, processors are getting faster, right? Caches are getting bigger, the NUMA awareness is better, hypervisors are getting smarter, and the storage is faster as well. So all of these put together, it makes a perfect reason for virtualizing most applications. And as you can see, with each version of VMware, right, with each version of ESXi, VMware has been increasing the performance and scalability by leaps and bounds. I mean, and any lingering performance concerns relating to VMware virtual machines, they are clearly due to a lagging perception from an early generation, right? From early generations, we basically, yes, we agree, it had limited capabilities. And at the bottom of the slide, if you see, there is a config max, a link, and definitely I have a slide, we have a slide that speaks about some of the configuration maximums, you know, how big and how large a virtual machine can go to. But do you have anything to add here, Don?
Yeah, I've got an important question, Sudhir. What are we going to do with the next version? We're not going to be able to fit it on this slide.
We just have to come up with another slide that says to be continued.
No, but this is classic. I'm not sure.
Yeah. All right. So when we announced the general availability of vSphere 6.5, November 15, 2016, there was a lot of features. There were a lot of features that were announced as part of the release, right? Some of the important features, and of course, I mean, there are not all of them are listed here, but some of the important features which are very critical and essential to business critical application are listed here. For example, the vNUMA, the fact that we were able to decouple the cores from socket, the fact that you're able to provide 4 NVMe or 4 virtual NVMe adapters with 15 target seat each, right? The fact that you're able to provide persistent memory capability to virtual machine, which can either be consumed as a block addressable or that can be byte addressable as well. The fact that you can use para-virtualized RDMA drivers in your virtual machine. And the use case here is Oracle Rack, private interconnect. The fact that we have the 512E drive support, right? And then with 6.7 that we released on April 17, 2018, right? April 17, 2018, we were able to increase the host processor from to 768 logical CPUs and essentially 16 terabytes of RAM. And then we all have heard of huge pages or large memory pages of 2 megabyte. Essentially, we came up with a 1 gigabyte large page as well. So even though Oracle does not have or is yet working on the large page size, ESXi, we are there. So we have a large 1 gigabyte large page, right? And the fact that, you know, we spoke about the persistent memory capability, we were able to hone on to that. So we were able to consume it both as block and byte. And again, you know, we were able to provide the 4KN local storage support as well. Do you want to add anything to it, Don?
Not to hear. I think down at the bottom a couple of things. So go ahead.
Okay. All right. And then at some point of time, we released vSphere 7.0, which was released on April 2nd, 2020. And essentially, there are a lot of features, but we're just listing out a couple of features here for time constraint. Essentially, the improved distributed resource scheduler, the improved DRS, the fact that we have what's called the assignable hardware, the fact that we actually refactored vMotion, right? And of course, you know, we have vSphere with Kubernetes, vSphere Lifecycle Manager, the fact that we have intrinsic security. But we'd like to take a couple of minutes and talk about the assignable hardware and a bit on the improved DRS and also on the refactored vMotion. But even before that, let's touch on the persistent memory feature that I mentioned, both as part of 6.5 release and also 6.7 release. So we all know, I mean, accessing data on a storage device can be 1,000 times slower than accessing data in memory. But we need these storage devices despite their performance gap because DRAM is limited in its capacity and is very expensive. Plus, it's volatile, which means it does not maintain data upon power loss. So now we clearly can see how memory and storage are very distinct tiers, right? So customers have successfully run their business critical Oracle workloads with high performance demands on VMware vSphere for many years. deploying IO-intensive Oracle workloads, they require fast storage performance, low latency, and also resiliency from database failures. So essentially what persistent memory or PMEM does, it creates a totally new paradigm for application developers where they don't have to worry about managing the data across different tiers. So what happens is PMEM, it falls between two ends of the spectrum. Essentially on the left-hand side, if you will, you have the DRAM, right? And on the right, you have the flash storage. So as we all know, DRAM is expensive, DRAM is volatile. On the other hand, flash, cheaper, it's slower, it's persistent. So with the introduction of the new category called persistent memory, we are straddling these two domains. So essentially what happens is application can access persistent memory just like DRAM over the DDR bus with load store instructions. So you can have data which is byte accessible with latency measured in nanosecond versus microsecond. So which means you now have DRAM-like latency and DRAM-like bandwidth. So your persistent memory that offers greater capacity points and lower cost compared to DRAM. And of course, persistent memory, it uses a non-volatile memory technology. So if the power goes off, your data will still persist. Right? Did you want to add anything down here?
No, I think you've covered a lot of it. I mean, obviously there are still some limitations in regards to the classic VMware features such as HA and vMotion when you're dealing with some of these more advanced storage techniques, persistent memory and so on. But we're working on it and we're getting there.
Yep. All right. So, we mentioned persistent memory, the fact that, we released this feature in 6.5, 6.7, we honed it, right? So essentially, and how can the persistent memory be exposed to a virtual machine? How can it consume persistent memory? Essentially, there are two ways to consume it, right? Either using the persistent memory as a block storage, right? And AKA, which is what we call a VPMEM disk, or using persistent memory in a DAX mode, right? AKA the VPMEM. And there are some use cases here, essentially to accelerate performance of Oracle read log activity, right? You're able to improve the overall database performance. The second use case that we have is accelerating performance using Oracle database flash cache, right? So the primary cache, of course, as everybody knows, is the buffer cache, and the smart flash cache is the secondary cache. And blocks that are evicted from the buffer cache, they're destaged to the smart flash cache. So if needed, you can reread the blocks from the smart flash cache onto the buffer cache, and so there is no need to read from the disk. So now, using the Oracle database smart flash on persistent memory, you're able to accelerate the performance of the overall database. And last but not the least, there's also a potential reduction in Oracle licensing. So there's a white paper that basically speaks about these use cases, that talks about the use cases with all the metrics, and that can be found in the link in the slide here. So I'm going to move on to the next one.
I think one of the best things to say about this, Sudhir, is that you just simply make your overall Oracle experience better. When it comes to the point about licensing, it's mostly that you're able to more efficiently use the hardware that you've got. And part of what VMware is doing here is enhancing the staging capabilities that already exist in Oracle to allow you to just simply run Oracle better. I think it's an interesting moment to mention. You and I have both written books on Oracle on VMware, Oracle on vSphere. And one of the themes that's consistent, there's a number of them, but all the way through, is that Oracle and vSphere are probably two of the most, if not the most important pieces of software ever written. And they're perfect together in that they make each other better. And the previous slide you just showed has some excellent, really subtle, nuanced examples as to why. So go ahead, Sudhir.
Yeah, that's absolutely correct. So, we also spoke about para-virtualized RDMA drivers. So essentially, the use case here is accelerating your Oracle cache fusion traffic or your private interconnect by using PV RDMA drivers, for the private interconnect. But even before that, right? So what happens is, when we use PV RDMA, you're essentially exposing a dual function, right, using a virtual PCIe device. So essentially, you have a network interface, which is VMX Net3, and also the RDMA provider, which is the PV RDMA, right? Using that, you're able to deliver best of both the worlds, which means essentially you're able to deliver the ultra-low latency to applications along with the ability to perform live migration. So as we all know, the RDMA provider that plugs into the OFED or the Open Fabric Enterprise Distribution Stack, right? And this PVRDMA, right, essentially has the full support for vSphere RDMA API. You're able to perform live vMotion, snapshots are possible, high availability is possible. So ESXi, we are able to leverage the native RDMA stack and the physical HCI services for all the virtual machines. But I will talk about a use case, that's Oracle RAC, in the next slide. So moving on here, right? And as you can see on the left-hand side, you have the traditional model, which is UDP over Ethernet for the cluster interconnect. And then once we decide to use RDS, right, reliable datagram socket for Rocky version 2 fabric for cluster interconnect, right? What we can then do is use the PBRDMA drivers along with RDS over Rocky, right? And it gives you a lot of benefit. So essentially, you have what's called the reliable socket offload driver and IPC protocol. That's what RDS is, right? With low overhead, low latency, and high bandwidth, right? And essentially, by using RDS over Rocky, you're able to free the CPU cycles, right? And of course, using RDMA with RDS over Rocky, you're able to free the CPU cycles for application processing. Thereby, you're enabling your processor scaling greater than what you can with Ethernet. And this is completely agnostic to RDMA capable devices, and it simplifies implementation. This can either work over a RDMA capable Ethernet NIC or an InfiniBand HCA.
Sudhir, I've got a question for you. As I look at this, and I think people in general look at it, there's a similarity here to how some of the more sophisticated capabilities of Exadata works, isn't there?
That's true. That's absolutely correct. All right. So we spoke about vSphere 7.0, the fact that you had improved DRS, you had the assignable hardware, the refactored vMotion. So let's just take a moment and talk about the improved DRS, right? And what was the feature? What were the attributes in DRS that we actually improved, right? So what happened is vSphere DRS always used to focus on the cluster state. It is to keep checking if it needs any kind of rebalancing, because it could happen that one ESXi host, right, that's overconsumed, while another ESXi host in the cluster, well, that has less resources consumed. Now, and if the DRS logic determined that it could improve the cluster balance, it would what it would do is it would recommend and execute a vMotion depending on the configured setting. So that way DRS used to achieve the cluster balance by using a cluster-wide standard deviation model. So with vSphere 7.0, the new DRS logic, it takes a very different approach. What it does is it actually computes a VM DRS score on host, and it moves a VM to a host that provides the highest VM DRS score. So the biggest difference to the old DRS version being it no longer balances the host load. It means the new DRS, it cares less about the ESXi host utilization baseline. So what we're doing right now is we are improving the workload balancing on the cluster by focusing on the metric that we care about the most, and which is the virtual machine happiness. So important to notice that the improved DRS now it runs every 1 minute. So it provides for more granular way to calculate the workload balancing, which results in an overall better performance for any workload.
Sudhir, you just came up with, and I haven't heard you say this before, one of the best VMware terms I've ever heard. VM happiness.
Yep.
And
machine happiness.
I really think there's a lot of depth in that very, very simple description. And the reason there's so much depth in it is it has to do with the thoughtfulness that have gone into some of these new capabilities. Obviously, both vSphere HA and vMotion, as I said before, changed the IT landscape 15, 20 years ago. And people might say that, well, it hasn't really been that much done since then. Well, without getting into some of the discussions in regards to Kubernetes and Tanzu, these are subtleties here that have made these incredible features and capabilities that much better. I'll tell you, one of the reasons that I buy cars, whenever I go to look for a new car, I look for the thoughtfulness that has gone into the new versions of the cars, because for the most part, they are the same, and you might get a bigger engine or so on. But there's little things that make your life easier when you're driving. There's little things that make the operation of that vehicle better. And that's exactly what has happened here with the very classic, industry changing features that VMware's had for a long time, and that's what Sudhir just described to you. So I really wanted to point that out.
No, that's a good point. Essentially, we are now making workloads a first-class citizen, right? Because that's what we need to focus on now. So this is a great feature improvement. And let's touch quickly on the vMotion improvement on vSphere 7 because this is very key to running any workloads on a VMware vSphere platform. Well, the key takeaway is that, in previous vSphere versions or vSphere, in the previous vSphere versions, right, what we did was we installed what's called the page traces on all of the vCPUs or the virtual CPUs, right? And that used to cause a bit of workload performance impact. And what used to happen is during the stun time, we also used to transfer the full memory bitmap, right? What happens is for large or let's say for monster virtual machines, this could be a fair amount of data depending on the VM sizing, right? So then at some point of time, we decided, hey, we need to bring this whole vMotion capability back and we need to reduce the performance impact and, reduce the stun time. And that's what led to these improvements done for vMotion and vSphere 7, right? So in vSphere 7, what we do is we claim just one vCPU to do all of the page installing and all of the page firing, right? Which is basically the memory page which is overwritten by the guest, instead of doing this across all of the vCPUs configured for a virtual machine. Now, using this method is far so efficient because the guest and the workload can continue to utilize the vCPUs without interruption. Essentially, one vCPU will take care of setting all PTE or the page table entries in the global memory to read only, and what it will do is it will handle the page tracer installer and the page firing. And in the end, all of the vCPUs will still be needed. You have to use all of the vCPUs to flush the TLB or the translation look-aside buffer. But now this has been done at different times to reduce the performance impact. So essentially, all we're trying to do here is trying to reduce the performance impact and try to reduce the stun time so that your vMotion becomes more seamless, more transparent, faster than what we had in the previous versions of vSphere.
So, Sudhir, I'll stick with this theme of thoughtfulness that vMotion, again, something that changed the industry in so many ways, and so much for the better. But we know that there were sometimes difficulties with vMotion in regards to the fact that the amount of time it would take is dependent on the size of the VM and the amount of bandwidth available and the amount of activity going on in that VM during the actual vMotion transition, but then also at the end, what we call the stun time. In other words, how long it takes to complete the operation where everything has to pause to make sure that all of the blocks that were being written to on the source side have been properly transferred to the target side. Well, again, that thoughtfulness that's gone into making that as efficient and optimal as possible, reducing that stun time, so that especially when you're doing large numbers of vMotions at the same time or large numbers over a small period of time, has virtually a negligible effect. It's pretty amazing overall.
Yep. So these are some of the reasons to upgrade to vSphere 7. We spoke about some of the new features, the capabilities. So for sake of time, I'm going to move ahead. You guys will definitely get the slides, the deck at the end of the session. So, we spoke about the compute maximum a couple of slides ago. And essentially, this is here just to reiterate, right? Just to reiterate that, we can have a virtual machine which can sustain a workload, right, as large as 256 vCPUs. You can have memory as large as 6 terabyte of VRAM. You can have NVMe controllers, NVDIMM controllers. The number of VMDKs per PV SCSI has actually been increased from 15 to 64, which means now with a total of 4 PV SCSI controllers, we get a total of 256 VMDKs in total for a virtual machine, and every VMDK can go to the max of 62 terabyte. So essentially, we just have to do the math of 256 into 62, and that's how much storage a virtual machine can address.
It's a lot.
It's a lot. It's a lot. Right.
So again, I'll mention this as well. 6 terabytes from an Oracle perspective in terms of RAM may seem to be a lot, but when you start getting into the arena of in-memory databases, particularly in-memory database management systems such as SAP's S4HANA, that isn't a lot. And so we will see us moving in the upward direction as the different versions of VMware vSphere come out over the next number of years. But it is a lot, but we're going to even go higher.
Yep. All right. So let's take a moment and let's have a look at this flowchart. Let's have a look at this flowchart here. So essentially, right, if you look at this flowchart here, the Oracle workload design methodology, right, essentially starts with the requirement gathering phase, right? And then at some point of time, we have to sell this project to the stakeholders. What we also need to do is understand current environment constraints. We have to measure the DB workload, the database workload. We also have to inculcate the database migration strategies, and especially we have to make sure that we inculcate design considerations for sizing. We have to make sure that we have backup, we have recovery, we inculcate high availability, disaster recovery. Of course, monitoring is of utmost important. Tuning is absolutely very important. But the key point that we're trying to stress up here is there is no phase in this methodology, or there is no point in methodology where basically stands up and says, this is different. This is different than what you do for a physical architecture. Essentially what we're saying is there is no change in the design methodology when one virtualizes Oracle databases or Oracle workload on a VMware vSphere environment. So essentially what we need is good architecture, best practices, and very good planning, and that would entail successful migration. Anything to add here, Don?
Sticking with the same theme, what you were doing in a non-virtualized environment, do the same thing in a virtualized environment, and you're going to be successful.
Yep. So let's take a look at some of the performance best practices. We don't have time to go through all of them. So essentially the guide, the link at the bottom of the slide here is the Oracle databases on VMware platform best practices guide. And some of the key performance, the best practices are essentially using para-virtualized SCSI drivers when possible, making sure that we avoid the CPU and the memory overcommit. And essentially we can also use memory reservation, making sure that we use huge pages in the guest, and absolutely distributing the Oracle operating system or the binaries, the data, the redo log files across all 4 PV SCSI adapters for queue depth and also for load balancing and fairness, using VMX Net3 adapters when possible. A use case here is the Oracle Rack private interconnect, right? We have to make sure that when we design our workloads, we design with NUMA in mind, and we also design for performance in addition to capacity, which means more risks equal faster workload. So, all right. So this is essentially an overview of migrating Oracle workloads to a VMware vSphere on-premises platform. So what happens is, as part of migrating the Oracle workloads from one platform to the other platform, the first order of business, we essentially have to identify the nature of the source platform, right? We have to identify the physical architecture. Well, that could be Spark Solaris Spark, or that could be AIOUG, or that could be the IBM AIOUG environment, which essentially is what's called the big endian systems. And as we all know, the big endian ordering places the most significant byte of the MSB first, and the LSB, or the least significant byte last, while in the little endian systems, essentially the Intel x86, the AMD 64, or even the 64-bit series of processors, the ordering is quite the opposite, right? So as we see, this is not a straightforward migration of Oracle data from the big endian systems to the little endian. This actually requires a block format change, right? So what happens is, second, the source could be the engineered systems, essentially the Oracle Exadata, the ODA, which are little endian systems running OEL. So the topic of migrating Oracle data from the big endian system to the little endian, well, that's not an issue here. And last but not the least, you could have your workloads or systems running on a non-VMware virtualized platform. Well, now we have to move that to a VMware platform. That requires, or that will involve, a virtualization format change as well, right? So the above migration, right, regardless of wherever you move from, right, whether it's a physical or the engineered systems or a virtual non-VMware platform, that should take into account the fact that you should inculcate best practices in every layer of the stack. So essentially the best practices guide for the VMware vSphere specific version, and the VMware best practices guide for running Oracle workloads on a VMware platform. So those two guides are essentially of utmost importance when one embarks on this journey. Anything to add, Don?
Yeah, we should add that we have a special program that's been around for a number of years for Unix to Linux virtual migrations. And that comprises 4 separate partners who are specialists in the area of Oracle on VMware, but particularly those migrations. They have a contract with us that, an agreement with us that specifies the actual cost involved, and it is a highly discounted rate. So if you are out there as a customer, they're all based in the United States. If you're out there as a customer and need some help in doing those migrations, we can certainly set you up with exactly the right partner to, in a very efficient way, help you go through that migration with our blessing.
Right. All right, so let's change gear and actually see what customers really want. VMware Hybrid Cloud. So essentially, as customers, they move to the cloud, they're looking for ways to get best of both the worlds without buying, let's say, new hardware, without refactoring or without replatforming. And essentially, they want to leverage their existing investments, the skill sets and tools. So with on-premises, they are able to use the familiar tools, the processes, they're able to leverage existing investments, maintain unique hardware configurations, have granular control over placement of apps and data, right? With public clouds, they are able to scale faster, they're able to reduce cost, establish global footprint. Well, you can have the pay-as-you-go model, or they're able to access even a broader range of services. So with the hybrid cloud here, right, well, today's complexity, that is actually hindering a full hybrid cloud value, because there are some of the common challenges, with the hybrid cloud adoption, namely the operational inconsistency, different skill sets and tools required, the fact that you have disparate management tools and security controls, inconsistent application SLA, the fact that you have multiple virtual machine formats, right? And if you actually happen to look at the application and the infrastructure rework, 60% of that is cost and 90% of that is actually time, time taken to do the application and the infrastructure rework. So let's have a look at some of the current offerings, right, that we have on the VMware Hybrid Cloud platform. And essentially, we have the VMware Cloud on AWS, which was GA'd on 2017. We also have the Oracle Cloud VMware solution, which was announced September 16, 2019. And then very recently, June 20th, a couple of days ago, we had the Google Cloud VMware Engine, GCVE, which was GA'd. And then we have the Azure VMware solution, which was GA'd May 2020. So, we basically have, a lot of options here for customers, right? The VMware Cloud on AWS, the OCVS, the GCVE, and the Azure VMware solution. And the link at the bottom essentially talks about these different various cloud offerings.
And here, I think I could add that the VMware Cloud Partner Program itself has many thousands of different partners. These are, of course, the ones we refer to as hyperscalers, and we all seem to forget that this all started with the IBM Cloud, which almost exclusively itself, even though it doesn't state that up front, but it exclusively under the scenes runs on vSphere.
Yep. All right. So let's take a look at some of the customer-driven use cases here, right? So for those customers that want to adopt the cloud, right? The cloud migration, or let's say data center evacuation, that is like the top use case. And that's followed by the DR or the DC extension, right? Some of the use cases, again, like I mentioned before, the data center extension, disaster recovery, you have cloud migrations, and then you have new generation applications, right? And if you look at the data center extension, essentially, right, the ask here is use the public cloud for on-demand capacity expansion for IT workloads. You're able to run your dev test workloads for the project duration. The fact that you're able to seamlessly expand for end user computing, seasonal workloads, so VDI, any of your published apps, and essentially provide scalable capacity for containerized workloads, right? So with the disaster recovery use case here, Oracle DR workloads, that can be scaled up in storage and also in compute. You could also use the VMware SRM or the Site Recovery Manager for replication and orchestration. You could also use traditional methods like you've been using before, the Oracle Data Guard or Oracle Golden Gate. And then you're able to complement the existing DR with existing solutions based on SRM or even vSphere replication. Now looking at the cloud migration use case here, one could migrate individual applications or even a set of applications, right? We could even have DC or data center wide evacuations. Essentially, mass migration tools and partners are available to do that, and you are able to migrate to the cloud so that you are able to have like a hardware or a software refresh cycle, or if you have to re-implement the Oracle, the software as well. And these are some of the customers here which basically have chosen to go this route. But then moving on, which is I think one of the most critical slides here, is essentially, right, we need to understand, we need to virtualize, accelerate, and finally reach for the cloud. So we have to read the documentation first, essentially make sure that we deploy these virtualized workloads in production with the best practices inculcated. And once we are able to do that, then use all of the vSphere new features that Don and I have spoken about in the session today. And then at some point of time, when we are ready to spread our wings, then make the move to go to the VMware Hybrid Cloud, and one has a lot of options here. So to summarize here, right? So, if you're looking at migrating Oracle workloads from on-premises to VMware Hybrid Cloud, like we mentioned before, this migration must take into account the best practices guide for VMware specific versions, also the Oracle best practices guide. Once we landed the Oracle workloads on a on-premises environment, well, the next step is, if you have to go to a hybrid cloud offering, you have all these options here, right? So this session is focused on the VMware Cloud on AWS use case, but a customer use cases for choosing the hybrid approach toward on-premises and the cloud that applies to all of the cloud offerings here. So let's move on. And I think, well, how are we doing for time, Don?
We've got some time, a little bit of time, about 10 minutes left.
Got it. So let's talk about deploying and migrating Oracle workloads on VMware Cloud on AWS, right? So as you can see, the VMware Cloud on AWS, right, together with the VMware Hybrid Cloud extension, HCX, that enables customers to accelerate their cloud migration in the simplest, the fastest, and the lowest risk way with compelling TCO. Essentially, VMware Cloud on AWS brings the VMware Enterprise Class Software-Defined Data Center, SDDC software, to the AWS Cloud, and that enables customers to run production applications across VMware vSphere-based private, public, hybrid cloud environments with optimized access to AWS services. So this VMware Cloud on AWS, this is essentially delivered, sold, and supported by VMware and its partners as an on-demand service. And that enables the IT team to manage their cloud-based resources with familiar VMware tools, which means we don't have the hassle of learning new skills, utilizing new tools. And if one were to open the covers, I'm simplifying this very much, right? If one were to open the covers of VMware Cloud on AWS and look inside, you essentially have the same, the VMware vSphere, the VMware vSAN, and the NSX, along with the vCenter, right, management, the fact that we have the robust disaster protection, and essentially you're optimized to run on dedicated, elastic, Amazon bare metal servers that is fully integrated part of the AWS cloud. Anything, Don?
Yeah, so I think some of the terminology is good to make sure everybody here understands. When we refer to hybrid cloud, that's an architecture that includes all of your multi-clouds that are part of your overall architecture, as well as your on-premises environment. And the beauty of each one of these clouds that Sudhir is about to talk about is that they all have different capabilities, and they all have different sweet spots in that certain applications on certain stacks that you have will work best. And obviously VMware Cloud and AWS is a VMware product. The others are products sold by the hyperscalers using the VMware Cloud Foundation VCF image, but they all have their own individual value propositions and use cases which are very good for them individually. So you know, try to keep those separate and think it out really carefully and really diligently when you make a choice on the hybrid cloud architecture. Go ahead, Sudhir.
Yeah, very good. So let's take a look at deploying Oracle non-rack workloads on VMware Cloud on AWS. Right? So essentially deploying non-rack workloads on VMware Cloud on AWS, that's exactly the same as one would do on premises. So as mentioned before, the VMware Cloud on AWS, essentially what happens is your ESXi servers, they traditionally reside in what's called an AWS AZ or availability zone, and they are protected by VMware vSphere HA. So this use case essentially deployed a virtual machine, right, from a template, and this was set up using OEL 7.4. This used 12.2 grid infrastructure, RDMA binaries, and the PGA and the SGA sizes are shown there. And what we did was we used the Oracle ASM filter driver that was used as well. Most important thing, all best practices for Oracle workloads on VMware SDDC, that was followed as part of the best practices guide. So again, just to reiterate, deploying non-rack workloads on VMware Cloud on AWS, that's exactly the same as one would do on premises. It's transparent, it's seamless. Now, deploying Oracle RAC on a VMware cluster, as everybody knows, that provides application level HA in addition to the infrastructure level HA provided by VMware HA. Now, steps to deploy an Oracle RAC on VMware Cloud on AWS, that's absolutely exactly the same as one would do on premises. The only subtle difference being the creation of a logical network for the Oracle RAC private interconnect on VMware Cloud on AWS, as opposed to creating a dedicated distributed port group that one would normally do on premises. But apart from that, the rest of the steps, whether it's provisioning or whether, let's say, it's compute or storage perspective, that's no different than one would do on premises. So the steps to create the logical network, that's actually shown here on the slide. I'm going to move ahead for sake of time. And now let's talk about deploying an extended Oracle RAC on what's called the stretch cluster for VMware Cloud on AWS. Right? And as I mentioned before, with the VMware Cloud on AWS, ESXi servers by default, they reside in a single availability zone and AZ, and they are protected by the VMware vSphere HA. Right? So a feature called the stretch cluster for VMware Cloud on AWS, that is designed to protect against an AWS AZ failure. Now you can have applications that can span multiple AZs within a VMware Cloud on AWS cluster, right? And essentially what happens is vSAN fault domains, these are configured to inform vSphere and vCenter, vCenter instances, which host is residing in which AZ, and essentially to increase clarity, what we've done is every fault domain is named after the AZ it resides within, right? And as everybody knows, extended Oracle RAC, that provides greater availability than the local or the traditional Oracle RAC, because that provides the site level high availability in addition to the application level HA, right? And on top of that, if you would run that extended Oracle RAC on vSphere, you're able to provide intra-level HA, right? So a very important aspect of any Oracle RAC configuration on VMware SDDC setup, we have to ensure that the Oracle RAC virtual machines, they are not scheduled on the same physical ESXi server. Reason being, because it would negate the HA proposition that VMware SDDC has to offer. So essentially, that's the infra-level HA. So what we do is, in order to achieve this, we have to specify the VM anti-affinity rules for RAC virtual machine. And what that does, it actually forces the virtual machine to remain apart during the failover actions. Now, in case of an extended Oracle RAC, which is essentially across multiple sites or AZ, best practices, spread the Oracle RAC virtual machines across multiple sites to ensure HA. In addition, right, because you get site level HA in addition to the infra and the application level HA, right, which essentially will ensure that all RAC VMs do not land on the same site at the same point of time. And how do we achieve that? We basically achieve that using what's called the compute policy tags and attribute that allows you to attach the metadata to objects in vSphere inventory. So the link at the bottom of the slide that basically goes into a very great detail into how you're able to come up with these compute policies, the tag and attributes, how you're able to assign that to ESXi host, how you're able to assign that to the Oracle virtual machines, the RAC VMs, so that you're able to now maintain the anti-affinity rules and also maintain that not all the Oracle RAC virtual machine lands in the same the AZ at the same point of time. And there's a YouTube video as well that essentially talks about it.
It's amazing how many different layers of high availability there are. As I've quipped about in the past, that if you architect this right, it would take a comet hitting the earth to actually bring the whole thing down.
Yep, absolutely. So this is, now let's take a look at how we can migrate the Oracle. I mean, we spoke about deploying Oracle workloads on a VMware Cloud on AWS infrastructure, right? Now let's take a look at how we can migrate Oracle workloads to VMware Cloud on AWS, right? And if you look at this picture here, this diagram here, the landscape, the infrastructure diagram, right? On a very high level, right? We can see that the Oracle workload migration can happen from on-premises to VMware Cloud on AWS on two ways. One, using the native VMware and Oracle methods, and second, using what's called the VMware HCX or the hybrid cloud extension, right? In this section, we will use the native VMware and Oracle methods to migrate RAC and non-RAC to VMware Cloud on AWS. So again, if we look at the architecture diagram here, essentially it's a three-site scenario, right? It's a three-site scenario. So you have the site A, you have the site B, and then you have the VMware Cloud on AWS, right? So the on-premises vSphere cluster on site A, that's running production workloads, right? And site B, that's running the dev, the test, the DR workloads. Both site A, site B, they are in what's called the hybrid link mode. Site A and site B vSphere clusters, they have access to their own dedicated storage. Site A is connected via layer 2 VPN to VMware Cloud on AWS, right? And this VMware Cloud on AWS, the infrastructure is essentially in a stretch cluster deployment. So you have a 6-node stretch cluster across 2 AZs, 3 servers in AZ1 and 3 servers in AZ2, right? And storage in VMware Cloud on AWS that's provided by the HCI vSAN instance. So if you look at this current solution, right, it basically designed and deployed 3 separate environments. You had Site A with a production 2-node Oracle rack, PRD rack on the left-hand side. It has a, with rack virtual machines, 01 and 02, right? It also had what's called the FARSync, right, the PRDFS, as we can see on the left-hand side. And on the right, on Site B, you had a DR2-node Oracle rack PRDDG, again, 2 rack virtual machines. And the key thing to keep in mind here is Oracle rack on premises that requires the shared VMDKs to be deployed with the multi-writer attribute. Essentially, that is what allows a VMDK to be shared among various virtual machines that comprises a rack cluster. And the requirement is eager 0 thick as per 212.1181, right? And the current restriction of multi-writer attribute is it disallows vMotion. Now, let's talk about migrating a single instance Oracle workload to VMware Cloud on AWS. It's very easy. Using the web client, all you have to do is right-click on the virtual machine, click Migrate. You select the compute, the storage, pick the compute resource pool, the storage, pick the destination network port, voila. Now, your virtual machine is now at VMware Cloud on AWS. And essentially, you would follow the same steps when you're migrating back to on-premises from VMware Cloud on AWS. So the blog that essentially talks about every step is there. There's also a demo, right? So let's move on to migrating an Oracle rack to VMware Cloud on AWS, and the version is SDDC 1.8 v2. The reason why we put the version SDDC 1.8 v2 is starting SDDC version 1.8, version 2, the shared VMDKs, which are in a multi-writer mode, that no longer be needed to be provisioned as eager 0 thick, which means you can use thin provision VMDKs. You can use thin provision VMDKs as shared VMDKs along with the multi-writer mode for your Oracle rack cluster. And that essentially means a lot of savings on the storage front for the customers. So essentially, I won't be going through each and every step as to how to do it, but as you can see, it's very easy. It's essentially step 1, step 2, and step 3. So for sake of time, I'm going to move on to the next. And as we spoke about the various methods of migrating Oracle workloads to VMware Cloud on AWS, the second way was using what's called the VMware HCX. That's the hybrid cloud extension, right? And again, you have the cold migration, the replication, the vMotion, and what's called the RAV, or the replication assisted vMotion. So let's talk about the second offering, and that's the Google Cloud VMware Engine, GCVE, right? And if you look at the GCVE, of course, every cloud provider, every cloud vendor, they have different features and different capabilities. But then the main parts, right, the major working parts for the GCVE engine, it's essentially the same. It's the vCenter, it's the vSphere, it's vSAN, it's NSX. It's not different here.
So again, everyone think of this and remember this as a VCF or vCloud Foundation image that has been customized for that hardware of that, in this case, hyperscaler. And this particular product is sold by Google.
Yep.
Go ahead.
Yep, sure. So essentially this slide shows, what do we get as part of the initial SDDC cluster. So per cluster, you can go from 3 nodes to 16 nodes, right? And then that's the model, the VE1 standard 72, essentially 2 socket 36 cores, 72 hyper threads, that memory is 768, that's how much storage you get. And of course, the network is 425 gigabits. So that's awesome. So essentially you have, a solid network here in this infrastructure, right? But then moving on to the most important thing, and that is the Google support for Oracle workloads on GCVE. So essentially, right, as we can see, Oracle supports Oracle workload on VMware the virtualized environments, and that's as per the Oracle My Support, the Metaling node 249.212.1, which essentially states Oracle customers with an active support contract and running those supported versions on Oracle products will receive assistance from Oracle when running those products on a VMware virtualized environment From a VMware perspective, VMware provides the total ownership support. Essentially, you get access to a team of Oracle DBAs within the VMware support. The fact that we can always reach out to TSA net collaborative support for any and all faster resolution of technical issues, and the fact that there's a great synergy between VMware support and the Oracle TSE when it comes to troubleshooting technical issues. But the best part of the proposition is Google's support for Oracle workloads on GCVE comes from Google. So Google is fully committed to support all Oracle workloads on a Google Cloud VMware Engine environment, and the Google Cloud support extends the support described to GCVE customers as well. And this is on the Google documentation. So essentially the link is there at the bottom of the site. So moving on for sake of time, let's quickly cover the Oracle Cloud VMware solution, the OCVS offering. So do you want to speak about this, Don?
Yeah, at first we have to mention that this is not yet general availability. It will be soon, we'll put it that way. This is one of two major aspects of the strategic alliance that was completed at Oracle Open World in September of 2019. Both Sudhir and I were there at the amazing moment, and he'll have a couple of slides for you in which Larry Ellison himself announced that Oracle and VMware were strategic partners. So Oracle became a VCPP partner, and that will result in the Oracle Cloud VMware solution. And we also were able to come to an executive level agreement on mutual support. So all Oracle products being supported on all VMware technologies. Of course, we've always known that since 2007, Oracle software is supported running on vSphere, but this is the first time there's been agreement between the two companies on an executive level to reduce or eliminate any ambiguity of this particular situation, which for a long time caused confusion in the industry. But now it's a great relationship overall, and we see it moving forward in very substantial ways. I think Sudhir here is going to talk to you about some of the unique characteristics of Oracle Cloud VMware solution and how it will really make sense, particularly for Oracle DBAs that are very used to having a lot of individual control over every aspect of the stack. And I think that's enough in the interest of time. Go ahead, Sudhir.
All right. So as part of the second offshoot of the whole strategic the partnership with Alliance, right? What also happened was the Metalink node was updated, right? That was a landmark update on the Metalink node 249.212.1. So essentially, it's a lot more cleaner, lot more neater, right? And thing to keep in mind: the support policy does not affect Oracle or VMware licensing policies, as Don mentioned. So moving on. So this is the minimum starting configuration for an OCVS cluster. Again, 3 bare metal hosts, 126 CPU cores, close to 2 terabyte of memory, and close to 153 terabyte of raw storage capacity. And like Don mentioned, GA is going to be happening sometime soon. So stay tuned. And then we quickly should talk about the Oracle Cloud Days on February 7, 2020, Dallas, where we had this keynote presentation by Jay Patel, right, SVP GM VMware, and Edward Scriven, Chief Corporate Architect Oracle. Essentially, they reiterated the synergy. They reiterated the strategic partnership between VMware and Oracle. So it's always better together. And I don't know if we have time to quickly talk about the support and licensing. So as I mentioned, you guys will be getting the slide deck at the end of the session. But to reiterate, VMware support will accept accountability for any and all Oracle-related issues reported by a customer. So we spoke about that. We spoke about the TSAnet.org consortium, which we could always reach out to take any help. Key thing to keep in mind, Oracle does not certify infrastructure. It only certifies the product operating system. So to be software compliant across the whole stack, the key things are, we have to make sure that we run a certified Oracle version on a certified operating system and run the same certified guest operating system on a certified ESXi version in order to keep both the vendors happy. And quickly touching on the Oracle licensing aspect, Oracle licensing does not change from a licensing perspective, whether you run Oracle workloads on a vSphere environment or whether it's VxRail or whether it's VMware Cloud on AWS. And as everybody knows, there are only three documents relevant for any Oracle licensing discussion: the technical support policy, the core processing factor table, and the OLSA and the OMA. But I think we are at the, the GSS, let me quickly talk about the GSS. So the GSS or the VMware Global Services, the team, essentially they're all very senior support engineers, and all of them are former Oracle DBAs. So they follow the Sun support model, right? It's a 24/7 support, and that comes for free for any customer running Oracle workloads on VMware, as long as they have either a BCS or an MCS contract with the VMware support. But Don, we are at the top of the hour here. So essentially to wrap up, a lot of licensing, there are a lot of collaterals here, which you guys will get at the end of the session. And this is the one-stop shop. Essentially any and all Oracle collateral, whether that's Oracle on VMware Cloud on AWS, or whether it's a best practices guide, or Oracle with persistent memory, or any of the licensing guidance, or for the matter, any Oracle collateral on any of our the hyperscalers. At some point of time, we'll definitely find a home here. But we are now open for question and answers.